Hello everyone, I am Dr. Vamangi Goswami. Today let us learn about stereochemistry of spirans in details, that is, presence of optical activity in absence of chiral carbon. This topic comes under Gujarat University syllabus B.Sc Chemistry semester 5, paper number 301, unit number 1A. So let us start. So let us first understand what are spirans. If one or both the double bonds of alkene derivative are replaced by a ring system, the resulting molecules are commonly called as spirans. So here in structure of alene, one carbon contains two consecutive double bonds. So one or both the double bonds are replaced by a ring system that forms a spiran structure. So in spiran structure, if one of the double bond is replaced by a ring structure, then carbon carbon and this double bond in between these two carbon is replaced by a ring structure and forms a structure of spiran. Another one in which both the double bonds are replaced by a ring structure, that is example of this here central carbon sp hybridized, two terminal carbon that is sp2 hybridized, both the double bonds are replaced by a ring structure. So number of years before optically active alkenes were known and the first preparation of dissymmetric molecule which does not contain an asymmetric atom was achieved in 1909 by Perkin, Pope and Walsh, who isolated both enantiomers of 4-methyl cyclohexylidine acetic acid. So the substituted methylene cyclohexane is dissymmetric because the groups attached to the first position of the ring. So here at first position CH3 groups are perpendicular to the ring structure, so it is dissymmetric molecule and does not contain plane of symmetry. A few similarly constituted double bonded nitrogen derivatives are shown below. Mills and Baum resolved the oxime O-cyclohexanone 4-carboxylic acid, thereby proving that NO bond is not collinear with CN bond. So here NOH is protruding out of the plane. Here all the structure is in the plane while NOH is perpendicular to this. So the plane of symmetry of this structure is absent. Due to this whole structure is optically active. Examination shows the two rings are perpendicular to each other and hence suitable substitution will produce molecule with no elements of symmetry, thereby giving rise to optically active forms. Here for an example, Mills and Nodler in 1920 resolved dialactone of benzophenone, that is 2,2-4,4 tetracarboxylic acid. Here these two rings are in the plane of paper while these two rings are perpendicular to the above ring. So this structure is optically active, while after reaction in presence of NaOH, lactone ring opens up and the whole structure will become flat and the presence of plane of symmetry is there. So in this molecule, the two shaded portions are perpendicular to each other, that consequently there are no element of symmetry. Where the compound is treated with sodium hydroxide, the lactone rings are opened up and optical rotation disappear. When both the double bond in an alkene replaces by ring structures, one obtains a bicyclic ring system in which two rings have one atom in common. Such bicyclic ring systems are optically active spirans. Here one ring is perpendicular to the other ring. So here plane of symmetry is absent. So due to absence of plane of symmetry, this structure is optically active. Pope and Whitworth resolved 5,5-pyrohydrantoin in 1931. So here 5,5-pyrohydrantoin is a similar flat structure which contains plane of symmetry, which has presence of plane of symmetry, while after reaction it forms another structure which has absence of plane of symmetry. So due to absence of plane of symmetry it forms a optically active structure. And lastly, Ponomarev and Zalenkov carried out partial synthesis of the optically active spirans. For them, they have used this structure starting material. After reduction in presence of H2 and nickel quartz, it forms 2,2-spiro bitetrahydrofuran, in which two ring structures are present. Both the rings are again perpendicular to each other. So due to that, this structure has absence of plane of symmetry. Due to absence of plane of symmetry, this structure is optically active structure. So this is all about stereochemistry of spirans.